Looks like it's time to start.
Yeah. Oh, okay. Now it's 9:30 local time, Bangkok. Let's start.
Yeah.
Welcome to the SNAC meeting. So the meeting will be chaired by Darren, my co-chair, and myself. Darren remotely and me myself here. So we have 2 hours, but I think probably we don't need 2 hours to cover all the agenda items. I should get closer, you mean? Right. Okay, thank you. So first, the note well, simply by participating in IETF, you agree to follow the IETF process and policies. You're aware that any contribution, if contains patent application or owned by or controlled by you, you must disclose it. You acknowledge that the text, audio, video, or recording of the meeting may be public. Personal information you provide to IETF will be handled in accordance to the IETF privacy statement. As a participant or attendee, you agree to work respectfully to other participants. The further note well, in case you notice any harassment or any concerns about that, you may raise that concern to the abundance team in IETF. A bit the meeting tips. Make sure you sign in the session via the data tracker. Or you can, the QR code is already gone, but you can do that from the website. Use the Meteo clients if you want to join the queue and participating in the show of the hands. Keep audio video off in case you not using that on-site version. Remote participants, make sure your audio video are off unless you are sharing or presenting during the session. Okay, so here is today's agenda. First with administrative stuff, agenda bashing, and then followed by a presentation from ESCO talking about the basically the prefix, multiple prefix of the ByteDHC IPv6 and others. And then we will give the time to Ted for the SNAC simple as the usual working session. At the end, we talk about any other business, next steps, and others. So, any comments, remarks for the agenda? If not, I consider the agenda is approved. So let's move to the next part. ESCO.
Yes, I'm here.
Okay.
Switching on.
So for me, I should stop sharing, right?
It works.
Oh, great.
Yeah, I'll just move to the slides now. I think I need to ask that.
Yep.
All right.
And did we click it?
I click pass the control to you.
Yeah.
Great.
I'm still working on the selection part. It's SNAC simple. It's here. Confirm your selection. So you should now be able to see it. So yeah, this is also SNAC simple, but focusing on a specific issue. So I can hope you can hear me okay here.
Yes.
then I'll just move on. Next page. So this is a diagram just to explain an example SNAC situation where this can be used. So we have basically SNAC routers here, or at least there's one on the picture, so which is also a 6LoWPAN border router. So basically the Stub network in this case is a 6LoWPAN mesh network, which could be a technology like Thread or another mesh network. And here we focus on the DHCP prefix delegation part. So you can see that the SNAC router has the PD client in there. That's the orange box. And that basically can get delegated prefixes from the DHCP-v6 server. That could be in a device like a CE router, for example. And that's on the top right, basically. So it gets a prefix. So one of the off Stub network routable or OSNR prefixes from the CE router. And now the example situation here, what we will talk about is what if there is more than one prefix in the delegated ones. And for the 6LoWPAN network, I have some reminders of the properties on the bottom right. So it's really low bandwidth network. So you can imagine you could have only kilobits per second speed in some cases for example, for a TCP connection. And all the nodes there are also low resource nodes. So resources being RAM, flash, and CPU. And there could also be other constraints. So, for example, that in this case, prefixes can also take up space in the network configuration data, and there's only limited space in there. So this kind of network prefers to have, if possible, only one OSNR prefix, and that's also related to these resource constraints. At the same time, there's also desire to minimize change of prefixes, so no churn if, for example, prefixes change, because every change also requires updating all the nodes with new network data. And if there are, let's say, a few hundred nodes, then that's also quite a relatively large operation. And finally, some nodes there might need a global IPv6. So that means a global prefix, so they can configure a global address with SNAC and then be able to reach hosts on the internet, for example, through the SNAC router and through the CE router. And you see on the left, there's a little note explaining the IP addresses that one node is storing here. So it has, in this case, for example, one OSNR address configured, one link local address, and optionally, there's also one realm local address, which is used for local communication within the mesh. So it stays with the mesh. And for these constrained nodes, there's typically also a limit in how many of these addresses they can configure. So this limit could be, for example, 3 as shown here. And in the thread case, there is even an additional address, local address that they have configured, and that brings it to 4. And some nodes have that as a hard limit for IP addresses. So in this case, it could be that there's only space for one OSNR address. So the node will basically look at the prefixes and be able to configure only one of those as an OSNR address, and not multiple. Okay, so this is the example situation. I'll now move on to the next slide. See what happens. Yeah, and when this prefix is delegated, you can have different kinds of prefixes. So as I said, you could have a global prefix, which is good for global connectivity, but at the same time could have some disadvantages because it may change over time if an ISP changes or upstream link is broken, so that the delegation from the ISP doesn't work anymore, or there can be some renumbering events. And the other type is the ULA prefix, which provides only local connectivity for the home, so it does not pass the CE router. And it can be provided by the CE router. I think that's also a requirement in RFC 7084. So CE router has some ULA configuration requirements. There is no requirement to actually necessarily delegate from that prefix, but that could also be implemented in home router. That has the advantage that it's really stable over time. And now we think that both kinds may be delegated by a DHCP-v6 server. And looking at the stub networks, you can also say there are different kinds of stub networks. In a very simple view, you can have 4 cases if you think about a binary distinction between low bandwidth networks and high bandwidth networks, and low resource nodes versus high resource nodes. So you could have any combination of those. So in the case I was considering, the mesh network, it's basically low bandwidth and you have low resource nodes. So both cases low. But there can be other stub technology choices. So you can imagine that this leads to possibly different preferences for stub router, or maybe profiles for this. So what the stub router needs to configure on the stub network. So is it, for example, one OSNR prefix that it selects, or if there are multiple, like would it select 2 of them, or maybe even more, 3, or another policy could be just have all available prefixes in the stub network. And that's fine if it's, for example, high resource nodes with high bandwidth network, then yeah, nobody probably really cares about that. So you can just pass on all the prefixes there and let the nodes make the selection. So to me, that suggests indeed kind of a profile that you could have depending on the link technology. Yeah, so that's one idea. Another idea is that you have one kind of standardized way to do this. That's basically to decide on how many of these OSNR prefixes will be passed onwards to the stub network. So what do we need to specify here? So the top sentence lists basically what we have in the current SNAC simple draft. So it basically says if the prefix delegation is available, the SNAC router must attempt to acquire a prefix using PD. So that sounds like we require at least one prefix there, or at least attempt to get one prefix, but it doesn't say anything about multiple. One thing we could do is actually think about selection criteria and also specify that in draft. So if there are multiple prefixes available, they could be of different types, like EULA versus global. There might be a preference for that. As I said, that's a bit of a difficult choice because, yeah, sometimes you need properties from both. Basically, you want the stability and you also want, for some nodes, the global connectivity. Also, the prefix length could be a selection criterion because we have some rules about /64 or shorter or longer. So at least we can ignore the ones that are longer than /64, as we have in the current requirements also. You could look at preferred and valid lifetimes, because I think it can actually differ, if I got that right, at least in the looking up the specifications. So you could say for, okay, let's go for the one that's longer valid, could be better. And there's also other options basically that are distributed or potentially. So there's the status code option in the IA prefix option, so it's embedded in there, and there could be others as well. So I'm not fully aware of what information could be in there and if it could influence the decision or not. And there's a GitHub issue related to this linked here, so that's 99. So we can also collect ideas here or discuss in this meeting. So that's basically the outline of this issue basically. Maybe we can move back to this slide just to see if there are any questions or suggestions for this or ideas. I see some chat by Christian already. That's basically both kinds are delegated by a CE router. I see Ted in the queue.
Yeah.
And now begins the long hike to the microphone. So, this is a hard problem because we have a good reason to want to use the ULA prefix, and we have a good reason to want to use the GOA prefix.
Which could be pointing to two, basically, right? So two types are available.
Yeah. So if we, I mean, the valid lifetime is not really a very useful guide because that's just how long you have to renew the lease. It doesn't mean that it's going to actually expire at that time. And I don't actually see a clear way to work around this. Basically, to me, the at least for the I mean, obviously for unconstrained networks, we just take them all. Like, there's no reason not to, right? We already have rules for source address selection, so it should all just work. For constrained networks, if we really do want to pick, I mean, we do have this option, right? We could pick, or we could use both. If we use both, that consumes more space. I mean, that means all of our update messages get bigger. If we pick, then if we pick the ULA, that's likely to be much more stable, but not guaranteed. Generally speaking, we expect the GUA to be stable. Obviously, there are exceptions. We're back in the TerraStream days. There was this plan to rotate them every day, but I think generally the GUA should actually be pretty stable. So, and the downside of using ULA is that you don't have connectivity to the internet with that ULA, and I don't think we want to propose that some sort of network address translation or something like that be used. So to me, it seems like the GUA is kind of, my personal preference would be to lean towards the GUA, but this is not like, this is a hard problem, and it may be actually just like a per application situation. But the problem is if you've got something like a stub router that's auto configuring, they all have to make the same decision, or you're a little bit, screwed. So given the vagaries of stub networks anyway, like stub routers can go up and down. When they do, the prefixes they're advertising go away. We renumber. There's a cost to that. I think this is just one more thing that could cause one of those events. And so I would be inclined to say that in this scenario, we just pick the GUA and don't pick the ULA, and that should be enough.
Okay, thank you. Yeah, that sounds reasonable.
So Eric Vink, no specific hat here. You summarize it well, right? So ULA should be more stable and global is more important. I would shoot for one ULA and one global because they got very vastly different properties. Now, what's the point? Because you can get now multiple ULA prefixes and multiple global prefixes. And then I think we need to get a sorting order that all SNAC router on the same L select the same prefix from the same big thing. So you saw the ULA first, the lowest win something, or the largest win, or whatever, something like that, to allow communication between stuff.
Okay.
That is a really good point. But there is an assumption that you made, which is that each router will get the same prefixes.
The same bottom.
Yeah. So, and also the prefix selection decisions to some extent hits the network. So I think choosing I mean, honestly, there isn't any particular benefit. So one router is going to have to make a decision about which prefix to use. It's possible that multiple routers will be making that decision at the same time. They will all propose prefixes. We have a strategy for what to do when we see two conflicting prefixes. So we don't need to solve that problem. We've already solved it. So what remains is just how does the stub router pick a prefix? And I think we don't actually care. Like, it can just pick the first one it gets. Except we probably want to wait a little while to make sure that we don't miss a GUA that we could have gotten. But realistically, a while is not going to be very long. I think best is going to be the enemy of good enough here. Like, I don't think we're going to come up with a solution that never renumbers. I wish we could, but I don't think that's going to happen. So I think mainly what we should be focusing on is not so much stability, but just like, we need to make a decision, and the decision needs to favor GUAs.
Eric again.
Yep.
But if we have two routers, right, connected to the internet, sending to the receiver /48 from their ISP, they advertise /64, you get two /64. If one SNAC select 164 from ISP A and the other one from ISP B, all communication between the SNAC will go via the internet, most probably, except that the CPE is learning enough the LRIO.
Okay. So, team?
Yeah. One thing to note in the CPE PD draft, we specified that the GUA should be the first PD. So I think it's rule, I want to say it's rule LPD 9 in the CPE prefix delegation draft. And what that means is we put the GUA first and then the ULA second, so that maybe that would be the way to make the decision, to give people an option so they could pick the GUA first. Makes it a little bit less code was the general thinking when we added that. So that might be something for you guys to take advantage of.
So Ted Lemon again. I think Eric. I think to your point, the SNAC routers are probably not constrained devices, and so we don't need to be super concerned about that. Although that's a good point. I think it's fine for the SNAC router to have sort of a more, I mean, obviously, if somebody has a constrained device that is a SNAC router, then they could use the mechanism that you just described, and that would be a code size benefit. I mean, I guess so. I think to Eric's point, if you have a network like the one that he described, that is actually something that we're going to address in the follow-on to SNAC Simple, I hope. Because what's missing from your picture there, Eric, is there's no connectivity between there's no communication between the SNAC router and the routing plane of this somewhat complicated home network. And I think we want there to be that communication in order to make this work. That said, I mean, the SNAC routers are going to be advertising RAs on. So if it's two CE routers connected to a single home link, and the prefix delegation is happening on that home link, then the SNAC routers are going to be advertising RAs pointing to the prefix that they've configured on their local networks. So devices that are on and by the way, SNAC routers do listen to RAs. So this is a key point. So I think that the routing would still work even in the SNAC Simple case, assuming that the SNAC routers actually use the routes that they see and don't just monitor them. So that's something we might want to consider talking about in the document. So I think I think that trying to solve this problem by being clever about how we pick prefixes on the router is probably not the best plan. Or I guess what I'm getting, so the reason I'm uneasy about that is because I like the idea that there's a certain amount of randomness to how they're chosen, because if there is an issue with one of the ISPs, we kind of would like to switch to the other prefix. Like if you know, if the router, if the ISP router that gave us, actually, this is a whole can of worms. If the ISP router that gave us the prefix is no longer reachable, and we will know that, right? Because we're probing. If that's no longer reachable, then our prefix is no longer routable. And so now if there are devices on the stub network that want to communicate to the internet, they can't, even though they theoretically do have an egress. And that's the whole point of having a backup egress, right? So this kind of sucks. So, I mean, the inclination would be to renumber when that happens. But of course, what if it's just a 2-minute outage? Now we've renumbered the whole IoT network at great expense for an event that was actually not long-lived. So I think, I mean, I guess the first thing I would say about this is that I think we need to talk about this problem in the document. But I think, as ESCO suggested, it may be that this is a per device profile thing, or per case profile thing. So like our sort of core use case is thread. And in the thread use case, what I would be inclined to do here is say, okay, we're going to pick the GUA prefix because that's safer. And if the router that gave us the GUA prefix is not alive for more than some period of time that's reasonably long, like long enough for one of these routers to reboot and reconnect, then we'll switch the prefix. But a 5-minute outage is not worth fixing at the cost of renumbering the whole network. So that would be the trade-off that I would make for thread. But for some different network infrastructure, a different trade-off might make sense. In particular, like if we have like a Wi-Fi to Wi-Fi stub router, SNAC router, we don't care. We'll just advertise all the prefixes and let the host sort it out. So I think that sort of solves that problem. Well, it's then we have a whole another set of problems, which I'm sure Jen would love to dig into. But anyway, so I think if I can sum up all of the ramblings that I've just made here, I think that what we should suggest is that in constrained cases, the constrained device needs to pick a router. It probably should be a GUA. It might want to have some hysteresis in place to avoid rapidly switching between prefixes just because of a temporary outage, and leave it at that. Oh, and also point out that stub routers need to listen. You need to actually use RAs for routing, or else routing between two separate stub networks won't work. So I think those are the 3 items that we need to capture. I hope somebody's taking notes. Stuart, taking notes?
Maybe it's a good time to ask the question about the note taker.
Yeah, sorry.
Yeah. So yes.
No, we do have a couple notes. Go ahead, David.
Right. Yeah, and of course that taking notes on my great proclamations here, maybe I'm wrong, so I would be happy for somebody to debate me on these points.
Okay.
We've got some more folks in the queue as well.
Yeah, I put myself in the queue just as a point. I think we need to also at least say that this behavior can be sort of different per stub network technology. So that's basically the profile idea. So it's true that all devices are default configured, so they have to act in the same way, but this could still be different per technology that is supported, right? If you know that it's Wi-Fi or Ethernet or a thread and mesh network, you can basically, pre-configure your stub router for that technology. So that's all I wanted to say.
Okay, Christian.
Yeah, we don't hear him.
We don't. Yeah. Christian, can you hear us?
Sorry, system global mute. Better now?
Yes.
Okay. If we can anyhow manage to make this more of a host choice, I think that's the preferable solution. Because if we have profiles per network, just because there is a particular application we expect on that network, that means that if multiple applications come in, we have that whole situation of having multiple networks in the same space on the same link layer technology. Once more, that the kind of IoT concept is trying to avoid. So if we manage, let's try to get this per host and advertise things both for like a default configuration and for slightly more capable devices that can say manage 2 GUAs to stay alive during a rollover.
Matthias?
Yes, Matthias Kovac, Siemens. I heard quite a discussion about the challenges if we have the global connectivity, multiple ISPs, and that there might be instability and so on. On the other hand, we are discussing the constraint case where we have to pick something. At least what I have seen, constraint case usually means machine-to-machine, IoT, automation kind of applications, where it is quite often important that it remains functioning locally, even if your internet connection goes away. So I missed a bit the point where we settled it has to be only one, because as it was said earlier, the global and the local, they have very different properties. So I am more actually in favor to say the minimum is 2, that we can have this stable local EULA to keep the local services running, because that's for the constraint case, in my experience, usually the case. And then we have this other slot where we can then deal with all this instability and the complicated cases that were raised. So was there an argument? I didn't pick it up, why we arrived that we have to make the minimum 1.
Yeah, that was some in my slides. Basically, there was for the thread case, for example, there's global network data that is distributed basically through the mesh network, and that's something that we try to keep as small as possible. That's one argument, and well, not the strongest one. Then you can have two in there. So the other argument is that some nodes only configure one OSNR prefix, so they have the slots already taken with other addresses. So there's then space for one OSNR prefix, and they can basically pick which one of the prefixes gets used for that. So they can, if they need a EULA, they could theoretically pick a EULA. If they need a GUA, they could pick a GUA.
Okay, yeah, my opinion is I would rather go for 2 because of these cases. If it's constrained, usually there's the expectation that the application continues running locally, even if the online connectivity goes away.
Okay. Masano?
Yes, I'm Masanobu from NEC Platforms. I think it's so hard to choose GUA or ULA, etc. So what if we use 6724 default address selection policy? So if you don't like it, you can change your policy with the configuration. Just a comment.
Okay.
Okay. That.
Yeah, so many good points made here. It occurs to me that certainly for constrained devices, communicating to servers on the internet is probably the less usual use case, as I think Matthias, right? Yeah, as Matthias mentioned. So maybe one way to think about this is that if we have a constrained network where we really don't want to add the extra 8 bytes, is it 8 bytes? Yeah, 8 bytes of prefix to a common data structure, then one thing we could do is simply have the border routers signal that GUAs are available. And if a device wants to communicate globally, it can elect to request a GUA through some other means. And then we aren't bearing that burden across the whole network. I don't know if that would solve our sort of dilemma here, because then we could just say, distribute the ULA to everybody, because that's the thing we need to communicate in sort of the normal, let's say normal use case. And then if some device wants to communicate off network, then it does a little extra work, and maybe that's okay. I mean, the other option is to just suck it up and like put both prefixes on the network and not worry about the extra space consumption, which, you know, there's a case to be made for that too, because this is, it's 8 bytes. Well, probably more than 8 bytes, but not much more than 8 bytes. And the challenge, and then that gives the node the opportunity to choose, do I pick the ULA or the GUA? And a node that wants to communicate off link can pick the GUA, and a node that doesn't care just picks the ULA. Or a node that wants to communicate off link might pick both because it's got more capabilities. And then we don't have quite as big a dilemma.
Yeah. Maybe can add something to that. So there was some interesting chat going on. So was the side note that yeah, not all CE routers today do actually do that prefix delegation, but we expect, of course, more of them to do that in the future. So we're already factoring that in. And one other interesting thing is that the CE router could be configured so that even though the SNAC routers are not configured, for example, by a home user, it could be that that user does take time to configure the one CE router they have. So you get a kind of half configured network situation, right? So then ULAS could be enabled for delegation, or it could be configured to only delegate GUAs or both maybe. So we have to also take that situation into account. So that's interesting.
Yeah, Tim, what does your document say about that case?
So yeah, a couple of things here. One, I've not seen a CE router with the capability of delegating ULAs behind it on the LAN. So they'll do GUAs if they get it, you know, big enough prefix on the WAN side. But I've not seen one in the wild that will actually take a ULA if you configure it to be bigger and provide that to a downstream router. I think that's a new concept that I've not seen any device do in the wild. So you know, this is kind of planning for the future, obviously, where that might exist. But today, I'm not aware of anybody who is capable of deploying this. And actually, some of the implementations I know actually prevent this from happening. They don't want a user to accidentally give out, or at least that's what they thought at the time, give out ULAs through PD. So I think that's going to be one issue. So that's something to think about there. And then on the other side, you know, we give out all of these prefixes from the 7084 ISP, the edge router in this case, right? Well, it'll send out prefix and give them out, and however many. But as I mentioned, you know, it's all basically theoretical because I've not seen anybody give out ULAs at this point. Does that answer your question, Ted?
Yeah, I mean, yes and no. What I was really concerned about is what your document recommends, because we're doing 7084 BIS.
Yeah,
right?
right. Yeah, 70. So well, there's two things here. There's the prefix delegation draft that went through IETF last call that has to have some updates. What that one says is you can provide both. You should be able to support ULAs, and that's new. So that's why we haven't seen anything. And then it says if you're giving out both, that you should give the GUA before the GUA option before the ULA IAPD option. is what we're currently giving on guidance for that. 7084 biz, we haven't updated any text to say anything about in that document. We've not touched any of this yet.
Okay.
Yeah, so it's also useful to consider that. Sorry.
No, go ahead. Sorry, I was
yeah.
actually urging you to speak.
Okay. Yeah, so we have the situation that the default, let's say what the SNAC router does, if PD fails basically or it's not available, it will basically create a ULA itself. So you could also say that the ULA is like the most basic level of connectivity. So that's not, it's not bad in a way to delegate a ULA because you have that, but maybe it's good to have the GUA as a kind of step up from that. So yeah, an additional feature that can get enabled in some cases, and maybe they are rare cases today.
Yeah, I mean, one thing to think about, Ted, that I haven't thought nearly enough about, and maybe others will think about this some more, is we could, by default, say if you don't have a PD, you could give out ULAs on the backside of a 7084 router. But that's new, and I'd have to think about that a little bit more if that's really what we want to do.
So there's a couple things that would need to be updated, or I don't actually know what the current, I don't think 784 really talks about this issue. So when you delegate prefixes from a CE router, all of there are CE routers that will delegate prefixes. I haven't encountered one that actually sets up the routing. So you have this prefix that you've been delegated and you start using it and you don't have global access anyway because your packets don't come back to you. So you can send packets out, but they don't come back.
No, we've seen that work. I have good news for you, Ted. That does work.
I believe you. I believe you. What I'm saying is like that certainly is not something you can assume will work.
No, but
784 should say that explicitly, and we should say how to do it, because right now we don't say how to do it, and it's not clear how to do it. I mean, I've just been assuming that since the router gave out the gave out the PD, that the DHCP server can somehow configure a route to the next hop that asked for that PD, but not all routers seem to do that. So we should say that explicitly if that's how we want to solve the problem.
Yeah, that's in the new draft. The one that's going to the LPD5 is must install a route to the assigned PD with the next hop to who you assigned it to. Yeah, we covered that case.
Wonderful. Yeah. Okay, so that's that, and then the motivation for giving out ULAs in addition to GUAs is the same reason that 7084 says you should give out a ULA on the local link. It's that the ULA is going to be more stable. So,
yeah, but I mean, Ted, here's what I'll say about that is we don't say that.
Oh,
we're very careful in 7084 about saying ULAs are configurable and they may exist, and that's it. We don't tell people, we don't give any I'll say by default guidance or anything like that. I mean, you got to remember the original 6024 and 7084 were written during a time where ULAs were not as popular or as thought to be as useful as they've turned out to be. So that's something we can revisit, I think, in today's situation.
Yeah, I mean, when we talk about this, I guess I haven't read 784 closely in quite a long time, so shocking. But yeah, so I think that, when we talk about this now, that's what we say about why we want ULAs. Maybe we said that back then, but didn't write it down. Maybe we didn't actually think that then. I don't know. It's been a long time.
Yeah, it has been. It's a good question. My memory of that is some people wanted mentioned ULAs, and I'm sure it was for stability purposes. I just think at the time.
Yep. So anyway, the point is that there is a good reason to give out ULAs, I think.
Yeah.
And as you were saying.
Yeah.
Okay.
I'll make a note for that.
Yeah, this is Matthias again. So I don't have this use case or this operation running. So my use case comes from building automation systems where IPv6 is used basically as a field bus internally. At the moment, we use ULAs, but they are basically configured through SNAC, so it's not prefix delegation. But what I see happening is that if one of these, it's thread border routers in this case, goes away, there's quite this churn that you get the interruptions until the ULAs stabilize again on the backbone. And here I just have this theory that prefix delegation with a EULA address could help to make this part more stable, where we have many of these field bus networks that we want to manage in a better way. And it's focused on local communication. And in many cases, we really want to separate it even from the internet. So that's why I see a potential use case for these ULAs also being delegated. But I'm not, so I'm still trying to figure this out. This is not, we need exactly this. And so just pointing this direction.
Okay, Ted.
Ted Lemon again. So as Matthias was beginning to talk, I had a thought about how to solve this problem, which I think is, so this is actually, there's a policy issue here that we haven't actually talked about. And I think it's like, speaking as an end user who has IoT devices in their home, I actually don't want them to get the GUA prefix because I don't want them communicating on the internet, right? That's not like, that's, to me, that's a security issue, right? And it occurs to me that what we really ought to do is give the users a knob they can turn. So, you know, if you have a setup where, you know, you've got devices that are managed by a server in the cloud and you want them to be able to reach the cloud, then you might prefer one configuration. And if you have devices that do not communicate directly with the cloud, you might have another. We don't want stub routers to have this knob because we don't want the user to have to know to go in and configure the stub router. What we probably want is to have a default behavior and a way to override it. And that probably should be on the CE router, not on the stub router. And in order to do that, we need the stub router to signal that it's a stub router when it's requesting the prefix delegation so that the DHCP server can make that policy decision.
Okay.
Okay, Stub.
Stuart Cheshire, Apple. I was actually just going to say something quite similar to what you said, Ted. Remember, this is the Stub Network Auto Configuration Working Group, not the Stub Network Manual Configuration Working Group. And I'm not just being facetious. I think our priority here is to work out what is the sensible default that products should do out of the box with no intervention. And then on top of that, we can layer whatever manual controls we want for people who've got, like we're talking about the building automation or a home network with a knowledgeable user. There should be defaults that we can override, but our primary job here is to decide what are the defaults if people don't override them.
Yeah, I agree completely. And so the reason I suggest a knob is because if the knob is in the home router and not in the, or it doesn't have to be a home router, right? It could be the exact Siemens use case, right? The routers just say, well, I mean, in the Siemens use case, you probably just wouldn't give out a GUA, and so that would solve the problem. But if we have a way to signal, I am a SNAC router, and I am being used, well, we then have the question, like, you know, there's different potential use cases for SNAC routers, and I'm very focused on one, which is for IoT. So we could have a way to signal, you know, I am a IoT router, but that feels a little weird. I don't know. I mean, I'd like to be able to do something like we have this thing with router advertisements where we have the SNAC router bit. And we did that because we do want to treat SNAC routers differently than, say, CE routers. Like CE routers are authoritative, SNAC routers are not. This is a very different situation, but it feels like there might be an opportunity here to have some kind of knob that says, you know, I'm a SNAC router and I'm being used for this particular thing, and so you may want to give me different stuff than you would give to something that isn't a SNAC router. But since there could be different use cases for SNAC routers, I'm not sure exactly how we would signal or what exactly we would communicate. But I think that's a thing to think about. So,
Yeah, just to react on that, so we could have this option or flag defined already now, and then think in the future about what would the CE router do with that, because today it will not do anything with that information, of course. At least we can already have a placeholder for that if we want.
yeah, I mean, like I am a thing-to-thing router, for example. So,
Okay.
So we've had a decent amount of discussion on this. Sounds like there needs to be more. It sounds like there should be some discussion on the list. The note takers have done a good job, I think, of capturing the notes, and there'll be the recording. Do we want to maybe continue with the rest of the content for the meeting? Okay,
Yes, that's good.
terrific.
Okay, great. So very interesting discussion, much longer than what I expected. I think we have enough time. Okay, so let's move to the next agenda item. So I don't know, Ted, you want to take over?
so last time we did this, I just sat at my seat with my computer and ran it with the presenter mic. So I think that's a reasonable model for this.
Okay.
There are a bunch of issues in the issue tracker that we should probably go over. Fernando did a review of the document. Is Fernando in the meeting? No?
No.
Rats. I was hoping he would be, because it was a little challenging. Oops, that's not what we want. It was a little challenging because a lot of his comments seemed like they were not understanding. Why does it want me to do slides? So I asked for a screen share. I think you might have a request on your screen.
Yep. Okay.
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 All right.
Wow, that is grim. Okay, there we go. That's better. Yeah, so I was a little challenged by these questions because they seemed like, so Fernando, as many folks in the room here are probably aware, is an expert on neighbor discovery. And we're doing a whole bunch of things that are rooted in neighbor discovery, but we're not doing neighbor discovery per se. I mean, in a sense we are. We do things like neighbor solicits to see if a router is reachable. But it's not for the purpose of neighbor discovery. And so a lot of Fernando's comments seemed like they were rooted in an assumption that we were doing neighbor discovery and doing it in a weird way that he didn't understand and didn't like. So I'm not sure. I mean, I wish that he were here because we could have that conversation. So we got like this pile of comments or issues that have been created by ESCO on his behalf. Thank you, ESCO. And it would be nice to get through them because there's a lot of them and this is a great place for it, but I don't know if it really makes sense. So let me give you, this is the first thing. So yeah. So this is, I guess this is actually the whole thing. Is that right, ESCO, or no?
No, these are only the editorial ones.
Oh, I
so you could say that those should be easy to resolve outside of this meeting. So the other ones are individual issues, basically that need some discussion potentially.
Yep.
And
Okay,
we can
so
skip this one.
all right. Well, so can Esco, can you maybe do a PR while we're going through this? Does that make sense? No pressure.
Good, good point. I'm not sure if that's possible. I only have one screen right now.
Oh, okay. All right. Well, so I mean, I'm kind of in the same boat, but let's see.
Yeah.
I can actually switch away without changing the presentation, so maybe I can do it. So I don't understand what the question is. So this first one here. Do you know what he means here?
Just looking at it now.
I think that just means drop the DNS-based DNS because it's service discovery.
Oh,
Like 2 times DNS in there.
gotcha. So get
It's
rid
a
of the
bit-
DNS, the second DNS. Okay.
What he says is get rid of both.
Well, that wouldn't be correct.
Well, you can modify it as you want, of course.
Yeah.
Just DNS-based can be removed here.
Right.
That's fine.
Okay.
But do you want to look at the discussion items or this one because this?
Yeah, let's.
Yeah, this is
If
probably
maybe
not
we
the
can
right
move
use
past
of
the editorial stuff.
Yeah, good point.
That'd
Okay,
be-
so
yeah.
Yeah.
Yeah, so this is discussing a rationale for the value. So in Appendix C, there are these values provided, but there's no reasoning given. I don't know if we have to provide a reason for all the values there, but that's good point to discuss at least.
Right. Okay, so let me look in Appendix C. I don't really get the context here. Oh, here we go. Okay, so SNAC router sends periodic router advertisements. Okay, so cur hop limit, reachable time, retrans time. Well, there's also some formatting issues here, like TBD wait ref must be 0. I wish I could share both of these things. Well, I wish there was a way to share the app and not the window. Okay, so do we know what the? So this is coming from 4861.
I had thought, Darren speaking here, I had thought that the values that were pulled in were the recommended values from 4861. Were they not? This was struck me as something familiar that was added as kind of let's use values that are already defined elsewhere.
Right. So yeah, I think that's correct. The default hop limit to be used when sending IP packets. Oops. If the received cur hop limit value is non-zero, the host should set its. Okay, that's not helpful. The default value to be placed in the cur hop limit field. This value should be set to the current diameter of the internet. The value 0 means unspecified. Right. So, yeah, because the diameter of the internet is unknown and possibly cyclic. Yeah. So I guess we could put some text in that says we got these from. I mean, so really, I think by default we got these from RFC 4861. The question is there? Oops. Let's see. So a SNAC router are filled in the following values consistent with the message format given in RFC 4861. So we could add some text here that says where where there's no reason to specify a different default, we use the default from RFC 4861, and then we could say,
Sounds perfect.
yeah, and then we could talk about why we overrode the default. So, okay, so I'm going to start a pull request, which you won't easily be able to see. I apologize.
We Ted, and alternate for maybe some smaller things like this. We can add them to the notes, like kind of work items and
Yep, that's a good
closure
idea.
on this, and you can move to the
Yep.
next one.
Sounds good. All right. So
Yeah, I think once we made a decision on items like this, we just record it, and I think the
Yeah.
decision is to have some sort of a global note that these zeros communicating default will be used, like wherever applicable, because we don't want to change anything. Because if you add it per item, like every zero you copy paste the same text, it would be a lot of extra text.
Yeah.
So you guys can probably see the comment here. Just basically, we'll add a global note, and then if we have any specific defaults that we overrode, which is going to be a little bit of an effort because I don't remember if we overrode any, but we can just check. Then we need to explain why we overrode them.
Yep.
Okay.
That sounds good.
Okay, so we have a plan for that one. RA options add should send a single packet.
Yeah, so here the language is more like it's expected to do X.
Well, so you may
why
have
is that
seen the
not
recent IESG note about RFC 2119, but I think what we actually should say here is must. I think it's like RFC 4861 says that you can send multiple RAs, but I don't know of anybody who does it, and I'm not convinced that it works. So given that, I don't think that we should be encouraging implementations. We could say should, and the reason why you should is because it won't work if you don't, but that sounds like a must.
That sounds like a must, yeah.
Yeah, I mean, we could also say the reason why you should not send multiple is because we don't think it will work, which is arguably a should, not a must. But so you might have a situation where you know it will work, and so then you could send multiple. But I don't really see any utility in sending multiple. Like I don't see how we would get to multiple RA options. So why?
Ted,
Yeah.
I think this is coming from Slack Renam draft, which Fernando is presenting in 6 men. Yeah, so idea is to aggregate all information possible in one packet, so host gets everything. So on the other hand, the only reason when your router might ever want to send multiple arrays is situation described in my like Gula draft, right? When you try look like a different router, sending different link locals and so on, yeah? But in your case, yeah, I guess like I think the right text would be if it fits in one array, you must send one array. That's it, right? So yeah, I see where this like history of this comment is coming from, right? But I guess yeah, it could easily be a must.
Yeah, I mean, I just like I don't see a SNAC router ever having a big enough bundle to send. But you know, you do raise a good point, which is that we could have a SNAC router that's actually sending multiple RAs because it's masquerading as multiple routers, and in that case, it's perfectly fine. Like we don't object to that.
Yeah, and in that case, it would be following multiple times the same specification. So it's still a must for each of the individual arrays that it is sending then. Yeah, so I don't think we actually have in this document take that case into account because it's basically specifying multiple SNAC routers on one device then.
Yeah, I mean, what I would say is just like, this is a must, the only, sorry, this is a should, the only exception that we can think of is this, but we don't have a use case for it here, but if you need to, you can. Like, I don't want to tell somebody that their funky SNAC router that's doing something weird and cool can't do it because we forbid it for no reason. So like, but that would be the only case. So the only exception, I guess what I would say is the only exception is if you're doing something like what's described in Jen's document, which I need to go look up, but
yeah, okay.
Yep. Okay, so all right, rationale for values in Appendix B. Okay, so I think the answer here is the same as for, well, there's two issues. One is RC 2119 language. So let me just see. Router lifetime must be one. Yeah. So an active build with the following values. Okay, so I guess the question is, so like definitely the SNAC router bit must be one, right? And there are some must nots. But then things like cur hop limit are, I mean, there's a reason why we didn't say must there. I'm not sure it was a good reason, but the reason we didn't say must there is because we don't actually care, right? Like we specified these values because they're reasonable default values. But if somebody wants to put a different value in there for reasons that they know and understand, we don't object to that. So it's kind of up to the implementation. So that's why some of these are must and some of them aren't.
Yeah,
we
you
could
say
for
that
each of,
recommended, right? If we don't say anything about the value, so just the recommendation then.
Right. Yeah. So okay, that's a good way to think about it.
Ted, my only question here is I think just saying default to whatever the neighbor discovery says, right?
Right.
Use the default
Yeah.
values as specified and then walk away would be my strong advice here.
So there was a wish to explicitly say what all the values were, and that's why we put them in here. The fact is that this document is not normative for these values. So so I think, and I don't really anticipate some new document changing these values, so I'm not super worried about somebody, encountering an issue here. But
yeah.
Yeah.
Yeah, I mean, it is a little tricky, Ted, that way, and that some of them have been updated. Like we backed off, we upped the RA interval max, and we've messed around with a couple of them. But I can't remember in the 15 years I've been doing this. I don't think we've ever changed the default value of any of the neighbor discovery values. So, but yeah, I think if you specify them and then someone does update them, you're going to have a problem. So you should probably just go with what they say, what the default values are if you really don't care.
So I'm proposing that we should maybe even add this to both appendixes B and C. So, and then if folks can't, I don't know how much of an eye chart this is out in the world, but when no normative language appears for these values, the motivation for stating a value is to suggest a reasonable default based on RC 4861. In cases where normative language is used, it's because we need to specify a value that's specific to the SNAC use case and either recommend or require that value be used. So I think this addresses the question.
And Ted, just a quick note, the MeetEcho folks have come back in the public space and suggested that you can share the whole app and not just the window if you choose to do that.
Oh, let's give that a try. Hang on a sec. Let me just do this.
Yeah. Thank you, Eric, for spotting that.
Okay. I like how it spelled MeetEcho. Okay. Oh, wow. Profile views. All right. So can we reauthorize the sharing?
David, I don't see that request. Do you see it? Oh, there we go.
Got it. Okay. Allow to share window, allow to share screen. Those are my only options. So sadly, no. Rumors of the ability for this to work with multiple windows in the same app were probably related to Windows and not Mac. Yeah. Yeah, I'm paranoid. All right, so that was 124. All right, make it clear that Appendix B and C are normative. So is that really true? I mean, one point, this is a really good point, Esko. Thank you for raising it. This is actually discussed in the IESG statement that I was referring to earlier. And they say that appendixes are not normative, explicitly not normative. So the question is, so let me just look at an example of this. Well, right. The question is, do we, wow. Okay, so in fact, in section 5.1.2.3, it says the SNAC router bit must be set in the RA fields. The values of the MNO must be copied, et cetera, et cetera. So we do actually cover this outside of the appendix. So I guess the answer there is that so I don't think we want to take the normative language out of the appendix because I don't want to have somebody reading the appendix and not going back and consulting the text and mistaking the required behavior. But I think it should be the case that any normative language in the appendix is reflected in the base document. So we should go through and do a consistency check on that.
Yeah, so maybe just one example here was, I think, the should requirement for putting the information in one RA message.
Yeah.
That was also in the appendix.
But that's not in the base doc.
Oh, well, that's something to check then if it's in the base document.
Okay. So you wanted 117?
Yeah, can we take a look because I'm confused
Yeah.
about text very much.
Sure.
So I just looked in the text, and text seemed to be talking about preferences of NAT64 prefixes. We're still talking about array option, right? And there is no preference in that option.
So
what's the intention here? Like, am I missing something?
right. So I actually ran into that exact issue when I was writing the state machine, because what's going on there is that I was actually referencing something that's in the thread spec, but not in the RA. And it's not actually relevant in this case. What I wrote, and I can actually refer you to the text. Let's see if where is that? The NAT64 state machine. It might be helpful if you were to review this. This is a pull request right now. Here it is. So basically, we're assuming now that the NAT64 prefix is provided in a pref64 RA option, and so now so rather than using this preference thing, the idea with the preference thing was that we were trying to signal whether a particular NAT64 prefix came from the infrastructure or whether it was self-generated. Yeah. Right? If it's self-generated, it's got a low preference. If it's from the infrastructure, it's got a medium preference. If it's manually configured, it's got a high preference. But that doesn't make sense here. That only makes sense in the context of thread. So that shouldn't have been in this document. What I did instead was to make a distinction between publishable and unpublishable NAT64 prefixes. So so publishable with respect to a particular border route or a particular stub router. So if we have not seen a particular NAT64 prefix advertised in a pref64, then we couldn't publish it. So that probably means that it was self-generated by another router. We don't actually care. We just know that we can't publish it, right? The other case is that and this is sort of irrelevant to your question, but the other case is that we have seen it advertised in the pref64, but we don't have a route, so we can't publish it. Yeah, so that basically gets rid of the language about medium and low preference, and I think needs to be reflected in the previous section. So
I guess section 6 will talk about advertising with different preferences.
Yeah.
I think it's confusing here because
yeah.
pref64 we don't have.
Yeah, so I need to adjust the text in section 6 to match the NAT64 state machine. Thanks for pointing that out.
I have a very quick operational question. This is useful. I'm glad we're making progress on the document. I see on the agenda we also had a final any other business item. So I just wanted to ask now if anybody has any other business, speak up. And if not, we can use the remaining 40 minutes to continue this. So I don't think we have any, but this is your opportunity. If you have anything else to raise, please speak up so we have time.
We do. So
that's why I'm asking, so we allow enough time if there is any.
So I do not think it's in the document, but it's been on my mind for related to other drafts. I probably being too pedantic, but when we say in global versus ULA, we're kind of doing the wrong thing because ULA is our global scope. And I keep having this problem with other drafts when I'm writing global non-ULA address, global non-ULA address. So do we need a term for this, or we just start assuming that ULAs are not of global scope from address architecture perspective?
So that's exactly right, and we should fix that. We need to say ULA and not ULA and GUA. So GUA meaning globally unique address, not global address.
I just came up with the acronym GNU.
GNU?
Global non-ULA, but yeah, we probably need to. I keep thinking we need a term for this, probably. Not in this group, but.
Well, to Ted's point, I thought we're using GUA for that. If that's the wrong term,
Oh.
then you can educate me.
I think GUA is fine.
Make hey folks, when you're speaking at the mic, please raise your hand so that you enter the queue and we track who's who in the minutes. Thank you.
I apologize. I was not intending to have substantive discussion. I was just asking about the agenda. Sorry.
That's fine.
Okay, so Jen has raised the point about terminology. Noted. I think probably Jen and Ted can have a bit of a debate and we can resolve that. Do we have any other business? I'm just asking so that we don't run out of time if people were sitting here patiently waiting to raise something.
So the chair's due, and we'll hold back a few minutes at the end for that.
Thanks,
Stuart. But the certainly if anyone has things like for example, the state machine was published by Ted, or at least a pull request sent out by Ted last week. If anyone had review of that and wants to give that review now, kind of ask questions about it, that would be a good point to do that.
Yeah, this, in case anybody is curious, I did send a copy of the HTML containing the state machine to the mailing list a while back. So you should be able to look at what that looks like as a document rather than as an XML file. I've been schooled on the point that XML files are really hard to work with when we're doing stuff like this. Sigh. Okay, so moving back to issues. So I just added an issue for Jen's point. So let's go back to wherever we were in, let's see, so 2 guest devices on guest network. Did you have something? Okay. Okay, so issue appendix 1 says an additional feature is that the owner of the network can choose to isolate all devices. This is essentially the same as being connected to a guest network, except there's no other network. This need not be the same. 2 guests on the guest network might be able to share. Yeah, that's a good point. So yeah, I think the point that you're making here, Esko, is that in fact this statement is simply not correct. And so we need to fix it. Yeah, so we should, the point of this, wait, so what does the appendix actually say? Okay, in some unmanaged network settings, there is a guest network in addition to the main network. In this configuration of a SNAC router is added to the guest infrastructure network. No communication will be possible. The general intended behavior of the guest network is to isolate untrusted hosts. Okay, so yeah, this is a use case that does exist, and I think that the document should talk about it. However, it's also true that you can have, I mean, I would make the distinction between a guest network and an IoT network. not that these are terms of art, they're just the terms that I generally see people use in the wild. So a guest network is a network where we want somebody to be able to use our Wi-Fi and communicate with the internet, but we don't want them to have access to devices that are local. And so normally the guest network would in fact be configured the way that I described in this section. However, it's also possible for there to be an isolated IoT network, which allows for communication. And of course, they aren't necessarily called guest and IoT, and your guest network might be one that allows communication between different guests. So it's not, this is not a hard and fast. So I think basically what we need to do is just document both cases, guest networks that are isolated versus guest networks that isolate users of the network versus guest networks that don't isolate users of the network, and make it clear that we're talking about the case where they do isolate users of the network. So I can add that to the.
Hi, a comment, Bob Hinden. So isn't a guest network just another network? It's not.
Well, that's the question that's being raised. So the point is that, like, if you think about, if you go to Starbucks and you connect your laptop to the Starbucks network, and then you try to do a service discovery browse for devices that can do some common service like AirPlay that everybody advertises, you will find no devices, even if there are devices, because they're isolated from each other. So that's the scenario that I'm talking about here. And I think that the clarification is just saying we need to distinguish between that and the other guest network case, which is the one you're talking about.
Okay.
Ted, Mike, Darren Dukes here. Do you need to say that there are other things that, is this necessary to add to the appendix? Is adding something, or is it just like?
Well, I think it's worth making it clear that we're talking about a specific sort of networks, because right now we just say guest networks are always like this, and that was the objection. I think it's a legitimate objection. They aren't always like this.
Yeah, I'm gonna keep my hand raised as Ted's typing that. I want to mention a couple other things to the working group, and that is before we get into our second, and the second hour here. Timothy Winters has agreed to shepherd this draft. We've added him to the data tracker as a shepherd. I think we're getting very close to complete, at least on the open issues. The review from Fernando is greatly appreciated, and without it, I think the issue tracker list would have been fairly short. So we're getting to the point, I think, where we could get some help from a shepherd to move this along. That was the first point. The second point being that in order to get through the rest of the issues like this, and then the additional sections that are coming in, like the state machine, we thought it'd be useful to set up some working group meetings every other week. Once we're a week or two past this IETF travel, so people get back to their home countries and catch up on their sleep. Is there any? Do we have any comments on those two working group items here that I'm going to throw into the middle of this section?
So I like the idea of doing some interim meetings. We are now in the part of the year when my life is slightly less chaotic, and interim meetings are a great way to make progress. We've made a lot of progress doing that in the past.
Okay. Terrific. We'll set them up for every other week. They'll be pre-scheduled. They'll go to the mailing list. Everyone will see them. Everyone's welcome to join. We'll try to choose some times that are friendly to various time zones, and see how we go after the first couple weeks.
Okay, so looking at this particular comment, RA guard is discussed in section in Appendix A. The point is that stub routers won't work when RA guard is present. They just won't work. You're dead. That's it. So I don't see any reason to mention that in the security considerations because it's the security basically RA guard is about it's specific to managed networks, and the goal of RA guard is to prevent devices that might advertise RAs from screwing up the network, basically. Excuse me. And so I don't think it's not I mean, I suppose in a sense you could say that RA guard would be a denial of service attack against SNAC routers, but I don't think that's really an appropriate thing to say. And we do talk about RA guard and what would happen if you deployed it, which is you would lose. So I don't think we have an issue here relating to this. I don't think we need to add this to the security consideration. So that's what I'm going to say unless somebody objects.
No objections for me. Just wanted to say that, Ted, I did see your browser window just now, like a minute ago. You switched tabs or something, and I did see it. Now, in this case, not, but it worked like a minute or two ago.
Oh, it's because I had different tabs.
Right. Okay. Just so that you know.
Ted, out of curiosity, if the network provides IPv6, even if it does do RA guard, it'll work, right?
Depends on, I mean, to tell you the truth, I would have to go look at the RA guard spec and see. You're right, it might.
Connectivity ought to work. I mean, like one thing that won't work is if the ISP router is not able to do hairpinning, like for example, my ISP router, and if the RA guard prevents like the RAO from reaching other devices on the network, then it won't work. But generally speaking, it has a decent chance of working. So I don't know if we want to say anything about that.
Yeah, that's a good point. We can add that to Appendix A.
The other thing is like, ND, like RA guard and ND attacks aren't really the same, right? RA definitely has its own class of attacks, but there's also other attacks that you can mount using ND, like spoofing and things like that, or like denial of service or exhaustion attacks, which are technically like different.
Yeah, but basically whenever you connect a host to the network, you're subject to those attacks. So this is no different.
Stuart Cheshire, Apple, just to Lorenzo's point, I am not clear in my head, maybe it's written down somewhere, but how RA guard and prefix delegation interact is kind of interesting, because the idea of prefix delegation is I am delegating a prefix to you, and you can claim that you are the best router to reach that prefix. And RA guard says, no, you can't, I'm going to block it. So I don't know if there's a document that says how you do selective RA guard in the face of prefix delegation, but they seem on the face of it incompatible.
So it would still work if hairpinning works. It's only if hairpinning doesn't work that it wouldn't. So basically your ISP router is advertising a default route. And so a host that is on the network where RA guard is active will send packets to the stub network to the default router. And then the default router will forward them to the stub router, oh, will it?
Yeah.
Nice. So
if everything is working,
yeah.
hairpinning must work,
but doesn't. Well, so actually, Tim, maybe this is something we should add to RFC 7084 BIS. I don't know if it's already there.
It's not.
Go on, Tim.
Yeah, no, it's not in there. And to Stuart's question, there's actually a separate spec for DHCPv6 guard, which would really cause you pain in the prefix delegation side of things. So they're basically two separate docs. Everything I've seen are two separate. One is RA guard and the other one is DHCP-v6 guard, which does exactly what you think and murders all DHCP messages from things that aren't authorized to be sending them.
So Eric Vink, this time and first time of the week speaking as a Cisco employee, to reply to you, Stuart, we have an ArrayGuard implementation in iOS, I mean Cisco iOS, right? Not your iOS. And there is no connection between ArrayGuard and DHCP guard, as we call it. So we delegate you a prefix, but if you send an array back, we will drop it. I agree. I don't say it's a smart thing to do. I just simply say state of effect.
Just to make it clear, I mean, I think like if the various elements on the network behave correctly, then this will work, right? Because the way it's supposed to work is, you know, let's say that you're a stub router and you there's RA guard, but you get a prefix via PD. The network is sort of contractually promised it'll deliver you packets to that prefix, and if something on the sort of LAN sends them to the ISP router, it's supposed to hairpin them back to you because it delegated to you, and that's how it's supposed to work. And DHCP guard will prevent you or anyone else from sending DHCP responses, but you don't need to do that for that to work. You just got a prefix from the ISP router and it'll work. One thing to Tim, I don't know if Tim's there, but like it occurs to me that we have like this DHCP, like, you know, I don't know, like is the DHCP-v6 like LAN PD thing, is it past last call? Can we still put in wording there that says if you delegate, you must hairpin? Because you must, right?
Yeah, we say you have to install a route to the next hop, which is, I think we're okay, Lorenzo. Let me go back. It's still in, I have to make updates to it. Yeah. So I'll look at this text and be very careful.
Yeah, because mine will install a route to the next hop, but that route is only looked up if the packet comes from the internet. Oh no, actually what happens is, yeah, so that route is only looked up if the packet comes from the internet. So if something on the LAN sends something to my ISP router right now that's bound for the delegated prefix, it basically says, oh, it comes in the LAN, I'm just going to send it out the WAN, instead of like sending it to the thing that was delegated to. So we should say that if we still can.
Yeah, we can. I can add that. I mean, it's not changing the spirit of what we wrote. So I think that's just a clarification. So I'll stick that in there. Done.
I am so glad we had this conversation.
Yeah. So Eric Vink, again, this time as individual contributor. ArrayGuard could cause two problems about the SNAC array flag. So SNAC router, we now discover there will be other SNAC router. That's one thing. And in the case of multiple routers, they need to be very smart to do hairpinning among them. They could do it, right? Because they also receive the IO. But...
So the point is that if we've got two default routes, we might send it out the default route that doesn't have the hairpin setup, right? Yeah. So yeah, I think that's. I think we're getting at this point we're getting into SNAC complex, and so I think that's a legitimate thing that we should address in the next document. But for this, what was I going to say? Because it's not going to, right? Because they don't know each other.
I think the answer to that, if it's not written down already, is to say that when you're doing RA guard, if you delegate a prefix with PD, you should listen to the RAs that come back as a result of that. And maybe that's, and if that's not written down, maybe we can think about that.
If for the use case that that Eric was talking about, that doesn't help because the U is not the same thing that's going to be dropping the packet.
Yep. Doing RA guard in a way that doesn't break the network is extremely difficult, and I don't have anything more to say about that. I just wanted to enthusiastically second what Lorenzo said about writing down that hairpinning is mandatory, that if a prefix is delegated with PD, that ought to go hand in hand with installing the right routing to deliver the packets, regardless of where they come from. And the reason I'm taking up time at the microphone is I've done this enough, writing standards documents, that we can look at the document and reading it with the right context, say, oh yeah, we're comfortable. The wording we wrote in the document is correct. and that's fine. We don't need to change it. But a vendor making a product who doesn't read it with that nuance might have the bug that Lorenzo is describing, that the local hairpinning doesn't work, and then they ship a product that doesn't work, and then you end up with meetings trying to explain to them why they read the RFC wrong, and they say, no, we didn't, we read it right, and it's all finger pointing. So even up to auth 48, I think that kind of clarification that is not changing what the RFC says, but it's making it blindingly obvious, right? You must forward the packets regardless of where they come from. That's what we meant. Let's say it in clear English so that people making the products have no doubt about what they're supposed to do. We'll all be thankful later if we're clear about the RFC.
Thanks, Stuart. I'll make the change and send it to the SNAC list and get some feedback as well. But yeah, I will make sure that it's very clear.
So I just realized that there actually is a way to fix this problem, which is that the router that is doing prefix delegation for a prefix that is larger than /64 should advertise a route to that prefix with its RA, since it's not going to be killed by RA guard. And that would mean that we wouldn't accidentally, if there's two default routes, we're not going to accidentally forward this packet to the wrong default router, because we're not going to use the default route. We're going to use the more specific route. And if we have a router that's like a stub router that's advertising the RA, and that RA is seen on the link, that RA is a more specific route than the larger route for the whole delegated prefix, and therefore is going to we're going to send it to the right place if RA guard isn't present, and if it is present, then we hairpin correctly.
The good news is that a CE router by 7084 is supposed to must do this.
So it's supposed to advertise a route to its full delegated
It's supposed to
prefix.
must send an RIO, yes, for its delegated
Yeah.
prefix, I think. Yeah.
Sweet.
Yeah.
Well done.
This Ted, this just works, Ted. You're fine.
Awesome. Thank you. Yeah, I haven't read the document in a while, so I wasn't aware of that, and that's really good news. All right, so so our action item for this issue is that we're not going to update the security considerations, because I don't think that this implicates the security considerations, but we will add a little bit of text about hairpinning, just because I think it's worth, the appendix is basically just a sort of a explanatory text. Actually, let me just capture some of the other stuff we talked about here before we go on to the next one. Okay. So that was...
There was also a new attack vector mentioned in this previous item, so I'm not sure if we looked at that. So it does introduce a new attack vector. That's the comment by Fernando.
What's the new attack vector?
Yeah, that I wasn't too clear about that. So it comes from the mechanism where SNAC routers advertise different prefixes and one of them is picked. I don't know what the new attack vector is there.
I don't know what he's talking about. If he thinks there's a new attack vector, he needs to say what it is.
Yeah, it needs to be explained. Okay, that's fine. We'll keep that in mind.
Yeah, I mean, I think he's speculating here, and I don't think there actually is an attack vector. Oh, the attack vector. I think the attack vector he's talking about is that. Well, yeah, no, I just don't know. Sorry. Okay, so this was security considerations. Reason to deprecate prefixes after a mesh network partition healing. Okay, so yeah, so I mean, your answer here is correct, Esco. So I don't know if you want to update the document to add that, but yeah, so we don't want to just have like, you know, if the SNAC network partitioned, we don't necessarily want to keep advertising those prefixes forever. Well, I mean, I guess the thing here is, so I'm thinking about this. So if we imagine in the sort of Wi-Fi to Wi-Fi use case, then this comment is absolutely correct. There's no reason to deprecate the prefixes. And in the partition healing use case, it should be sufficient to just stop advertising whichever prefix lost. So in other words, you know, it's still possible, and this is something that we actually in the thread spec we say that for like 5 minutes after a prefix has gone away, it still has to be routable. Because there is no RA there, and so we don't do the same sort of deprecate. We don't have like valid lifetime and preferred lifetime explicitly. So it's more just handled implicitly, and the valid lifetime is always like 5 minutes from the last time you saw it. And the preferred lifetime is essentially 0. What's my point here? Yeah, so there isn't any reason to explicitly deprecate prefixes on thread, and there isn't any reason to specifically deprecate prefixes on Wi-Fi stub networks. So I think that the point, so basically the point is that we would then have to remember these prefixes until they expire so that we can advertise routes to them on infrastructure. So I think that's the way to address this. Comments?
Yeah, maybe one comment is that maybe the thing about network partitions and healing is also very specific to a particular mesh network technology. So like threads, you have that, but maybe that's totally not applicable for Wi-Fi or Ethernet or others.
Well, I mean, so, you know, Wi-Fi mesh can get partitioned, and that's a thing.
Okay.
But I mean, it's true. We could just not talk about partitioning here because at this point, you know, like in the thread spec, we don't actually, I mean, we do sort of handle partitioning, but we don't handle it in anywhere near the level of detail that we did when we started writing this document. So maybe just like being minimalist about how we talk about this is better.
Lorenzo?
To clarify, are we talking about prefixes in the stub network or prefixes also announced in the sort of infrastructure link?
So this would be a prefix that's announced in the stub network. So you've got let's say two partitions. You announce a prefix on each partition, different prefix. Now you're announcing routes on infrastructure to those prefixes. And the question is, what do we do? I mean, we actually basically we need to pick one and keep advertising that. We don't actually have to deprecate the other one. We can just stop advertising it. And if somebody still remembers it, they can try reaching it. And if the device that's on the other end still remembers it, then they're reachable. And if not, then they're not. The main thing is that the stub router, if it gets if it gets a packet that's destined for that prefix, it needs to not redirect or, you know, like if it's the router for that prefix, it needs to keep routing for that prefix as long as that prefix is still usable. But I don't think it even needs to advertise the route. It just needs to accept a packet and forward it if it can.
I mean, I think the issues that you get with partitions is that they, you know, often if something partitions, it's sort of likely to partition again and again and again, right? If things are flaky and things flap. And the reason I was asking about the infrastructure link is that if you flap and then you assign different prefixes and send different RIOs, then you'll like all sorts of bad stuff will happen. Like you'll basically hit the limit of the maximum number of IROs in the array. You'll sort of like have like you'll hit the maximum number of IPv6 addresses per interfaces that various SNAC implementations use. Like that's like all around like 16, 17, I think, all those numbers. But yeah, so if there's on the infrastructure link, if there's only one, which there ought to be, then that's fine. The other thing is like a lot of devices do very, very stateful filtering of arrays, like very, very sophisticated, and that requires sort of like very sort of scarce RAM on the Wi-Fi chipset. So if you send a bunch of different arrays, and those get LRU'd and stuff. But anyway, so yeah. But like I said, if this is all mostly for the stub itself, I think that's fine.
So I don't think this is a topic for this meeting, but I would love to hear more about that, Lorenzo, because that's news to me. Okay, so so I've just said that we should, if we stop advertising a prefix, we should continue routing packets, but we don't have to advertise a route, and made a note of the points that Lorenzo made about flapping, which I think are worth noting. Right now, I think certainly in the thread case, we don't actually do anything special, but we do so much work to avoid partitions that I suspect this is not really a use case that's going to happen much. And there's a case to be made that we should just not really talk about this in this document, because I think, you know, it's a weird edge case that's actually arguably just a failure that it's not our problem to fix. But I don't know if I'd be curious to know if anybody else has thoughts about that approach, actually.
So we have 8 minutes left. While folks are thinking on that, I had a request for the document that we add in the implementation statement, because as this document moves, Ted, I think you're wrapping up a lot of the kind of nitty-gritty issues with it, and I think we're going to be at the point to move it to the last call pretty soon. As such, we can get an implementation section in there. Folks could come and volunteer their implementation details of this or portions of the SNAC router specification. That'll be useful for the IESG once the document gets there.
Yeah, I mean, there are two implementations that I know of. There's the open thread and there's the Apple one. So yeah, I'd be very curious if anybody else is also implemented this.
Yeah, exactly. Yeah. So I'll put it on the list too, but folks in the call, we do have a decent audience. If anyone else has been implementing OpenWRT or anything else, then let us know.
Okay, so the next issue, this is issue 118, related to work on multi-router, multi-prefix. Fernando says, I think this is Fernando, that it seems that what you're describing will likely lead to a multi-IPv6 multi-router, multi-prefix scenario. If that's the case, then maybe the multi-IPv6 work that Fernando is doing is relevant. I think the multi-IPv6 work that Fernando is doing is highly relevant in the sense that we need to be able to operate in such environments, or we'd like to be able to operate in such environments. I don't know precisely how to handle that.
But this is Eric Vink here. Doesn't it belong to the complex?
Yes and no. I mean, so here's the thing. Suppose you have a home network that's got multiple egresses, and you've got a stub router, and you want the stub router to be able to take advantage of the multiple egresses, but you have a constrained network on the backside of the stub router, and so you don't want to be advertising a bazillion prefixes on the constrained network. What do you do? One answer to that is we don't actually care about ISP egress because all of our communications is local. In that case, we actually don't care about the multi-egress situation. We don't have to do anything about it. And actually, that's the case that I think is most applicable for Thread. Like in principle, for Thread, we want to be able to reach the internet for things like firmware updates and stuff like that. That's the main use case for reaching the internet right now for Thread, I think. But I think even that is actually handled by local devices. So it's a little bit hypothetical, the reaching the internet bit from the stub network, from the particular use case that we have. And if we were doing a stub network that was a Wi-Fi network, then we just would do, then we would basically do exactly what Fernando is alluding to here. We would, take RAs or take prefix delegations from all of the multi-hop routers, assuming that they support it, and it would just work. In the case of a stub network where we don't want to advertise so many prefixes, then we have to make choices and we have to fail over, and that gets, basically now we find ourselves renumbering.
We fall back to the discussion we had at the beginning of the meeting with ESCO. Okay, thank you.
Yeah, I mean, Bob Hinden, so Fernando made a presentation in V6 Ops about this. It was just a presentation. There is no chartered work. So I would think that delaying this, which is, I think, mostly done and ready to advance for that, I think the multi-homing work will need to take this work into account, not the other way around, if that's helpful.
Yeah, I mean, I think that's basically right. It's we're going to have to solve this problem, but I don't think we can solve it in this document without delaying this document for years, and we shouldn't do that.
We are just about out of time, so I'll try to be really quick. There are kind of 4 levels of connectivity. There's communicating on the mesh. There's mesh plus an adjacent infrastructure link, which covers most home residential networks. There's the mesh plus an adjacent infrastructure link plus other routed networks. That's a kind of enterprise scenario. And then the 4th level is all of that plus global internet. So those are the kind of layers of the onion here. I came to the microphone to add a bit of context. Ted, you were talking about what is the use case for global connectivity. Right now, I think it's not so much firmware updates. I believe Matter now actually has a firmware update service that runs locally. So a device, a Thread device that needs firmware can ask your home resident, get me this firmware, and then it's delivered locally. And that's really good for privacy reasons, that the customer knows that these devices not exfiltrating data. So I'm very much supportive of having a local firmware update service. I think the canonical use case people cite today for global connectivity is for things like a garden irrigation controller that wants to check weather forecast services on the internet to get data to predict whether they need to water. Over time, we can imagine a local weather forecast service that also runs locally, but there's always going to be a time gap when people are innovating and they have something they want to do. They need to talk to something on the internet to get live data, and there is not yet a local version of that. So when we want to give examples, I would leave firmware updates off the table because I believe that has been solved. But things like weather forecasts and other unexpected future use cases are the ones that are not solved.
Yep, that makes sense. Thanks.
Lorenzo, Kulidi, I think we can and we should actually do some minimal stuff for a sort of like dual home ISP network. I think I want to observe two things. First of all, like for hosts, there's a lot of stuff that's already actually written down in RFCs.
Just
And the second thing,
Lorenzo, sorry to interrupt you. We're at the end of our time, and this Meet Echo may disappear at any moment.
Exactly.
okay.
So
Let's figure out what it
keep
means
going.
for us
If you
computer.
get cut off, send it.
Okay.
Yeah. So the session was very interesting with a lot of discussion, but yeah, much longer than what I expected. But it's
That's
good.
good.
Thing. So we will schedule some interim meetings to continue our working session. Yeah.
Yeah. Thanks, everyone. Thanks, Ted.
Yeah.
And let's anything else. Let's continue it on the list. If anyone else wants to dive into these issues, please jump into the issue tracker in GitHub and add your thoughts. Thank you.
Okay, thank you. Bye.
Okay, we're adjourned, everyone. Thanks. Bye.
That's a shame.
So yeah, we need to figure out basically when we get two arrays, or we get PIO, we just need to make sure that we route the packet to the same as that PIO. Yes, it's actually fairly simple, right? And for complex, we can do a bunch of stuff. Is that in here?
That's already.
It's not written down anywhere, I think. I mean, like for hosts, we like basically say do rule 505, which is fine, but this is slightly different.
Yeah, I think Fernando gave us a big pile of work to get through. Yeah, I mean, the state machine is
kind of
really,
like 80-20.
I think I should publish a new version of the document that people can look at, otherwise it's a big thing, and based on the comments that Jen made, I need to update to account for the same things.
Something that you want to do.
They're running the show.